Okay, so we went over in class the top three series that you see at the top. That 1 over 1 minus x is 1 plus x squared all the way up. We talked about it because it was a geometric series, right? And an infinite geometric series has a sum formula. We also did the 1 over 1 plus x is 1 minus x plus x squared minus x cubed. So it's the alternating version of this top series. We also derived together what the McLaurin series of e to the x and sine of x were. So what I wanted to do in this video is just walk you through the derivation of cosines, McLaurin series. So the first thing we do is we think about cosine. Think about the general McLaurin formula, which is here. So we're going to start with n being 0. So we want the 0th derivative of cosine at 0. So that would be just cosine of 0, which is 1. X to the 0 over 0 factorial. And remember that 0 factorial is defined as 1. So when we go to the derivative of cosine, the derivative of cosine would be negative sine. So when I plug 0 into negative sine, that's going to give me 0. It's going to give me a 0 term. I'll go ahead and write it out. 0 x to the first over 1 factorial. Then I want to go to n equals 2. So I want the second derivative of cosine, which is actually negative cosine. So when I plug 0 into that, that gives me negative 1. And then this is x squared over 2 factorial. Going down to the next derivative, which would be the third derivative. The third derivative of cosine, I believe, is back at positive sine, and sine of 0 is 0. So then we have this. And then the pattern of the derivatives of cosine repeats. So we would have the next term being a derivative of 1, a derivative of 0, running out of room, a derivative of negative 1, and I'll kind of write this up here. It's a little cheating, but that's all right. And then another derivative of 0. So remember the 0 terms are trivial, so we're just going to ignore those when we go to write a pattern out. So the pattern that we've got then is basically that, which is all 1, minus x squared over 2 factorial plus x to the 4th over 4 factorial. And I'm sure if you looked at it, you bet that the next term would be negative x to the 6th over 6 factorial, and it would keep going from there. So then again, the way we actually get the McLaurin series for it is we label each of these a term number. So we could start this first term at 1, we could start it at 0. I think it's more convenient to start it at 0 because of all the zeros that appear. So if I call this term number 0, this is term number 1, term number 2, and term number 3. So really all I have to figure out is how to get the numbers in here from the term number that it comes from. And if you look at it, the pattern seems to be pretty clear. There's x to the 2n, is twice the term number, and then the factorial that's on the bottom is also the factorial of 2n. And then it's alternating. So then you have to figure out, well, we want the even terms to be positive and the odd terms to be negative, and that's how it works when you just raise negative 1 to the power itself. So in front of it, that would be negative 1 to the n. So then the McLaurin series for sine is n starts at 0, goes to infinity, and my term is negative 1 to the n, x to the 2n over 2n factorial. The way we did sine in class, you'll want to alter that slightly because I think we started it at 1. It's much more convenient to start it at 0. So these are the McLaurin series that you would typically be asked to memorize in this class, along with the 1 for 1 plus x.